अब ये जो क्वेश्चन हमें गिवन है ये हमारे पास सिंगल आंसर करेक्ट टाइप क्वेश्चन था। ये क्वेश्चन हमारे पास, इसमें हमें 4 ऑप्शंस गिवन थे जिसमें हमें राइट ऑप्शन को मार्क करना है। और ये क्वेश्चन इसलिए भी काफ़ी इंपॉर्टेंट है, रीज़न बीइंग कि ये हमारे पास 2016 में मेंस के पेपर में अपीयर हो चुका है। क्वेश्चन जो है वो हमें ये कहता है कि द हॉटेस्ट रीजन ऑफ बंसन फ्लेम शोन इन द फिगर गिवन बिलो। तो हमें बंसन फ्लेम गिवन था और हमें ये 4 ऑप्शंस गिवन थे जिनमें से हमें बताना था कि हमारे पास जो हॉटेस्ट रीजन बंसन फ्लेम का कौन सा है। ठीक है, तो जब हम ऐसे रीजन 1 की बात करते हैं, रीजन 1 जो है ये हमारे पास क्या होता है, ये हमारे पास होता है प्री हीटिंग जोन। ठीक है, प्री हीट होता है। फिर जब हम बात करते हैं रीजन 2 के बारे में, तो रीजन 2 हमारे पास क्या होता है, इसे हम बोलते हैं कि ये होता है हमारे पास प्राइमरी कंबशन जोन। ठीक है, अब ये जो हमारे पास प्राइमरी कंबशन जोन आता है, अल्टीमेटली यहाँ पर ही हमारे पास कंबशन होती है। ठीक है, फिर रीजन 3 जो है वो हमारे पास रीजन 4 और रीजन 2 के बीच में होने के कारण इसे हम बोलते हैं इंटरनल जोन। ठीक है, और ये जो रीजन 4 है, ये रीजन 4 को हम क्या बोलते हैं, रीजन 4 हमारे पास होता है सेकेंडरी रिएक्शन जोन। और इसका रीज़न क्या होता है कि ये हमारे पास एटमॉस्फेयर को एक्सपोज्ड होता है, इसीलिए हमारे पास यहाँ पर कोई भी सेकेंडरी रिएक्शन हो सकता था। ठीक है, अब हमें क्वेश्चन में पूछा गया था कि हमारे पास हॉटेस्ट रीजन कौन सा है। तो यहाँ पर देखो, ये सबसे पहले तो हमारे पास प्री हीटिंग जोन आता है, फिर उसके बाद हमारे पास आता है प्राइमरी कंबशन जोन। ठीक है, तो जब हम बात करते हैं प्राइमरी कंबशन जोन की, यहाँ पर हमारे पास अल्टीमेटली कंबशन कैरी आउट होती है और ये जो रीजन होता है ये हमारे पास हॉटेस्ट रीजन होता है एक फ्लेम का। ठीक है, तो रीजन 2 जो है वो हमारा आंसर होगा और वो हमारे पास कौन से ऑप्शन में प्रेजेंट था, वो प्रेजेंट था ऑप्शन ए में। तो हमारा फाइनल आंसर जो है वो है ऑप्शन ए।
Hello students, let's start the question. The question over here says that the main oxides formed on combustion of lithium, sodium and potassium in excess of air respectively are. So lithium, sodium and potassium, all of these are alkali metals, right? Okay, so alkali metals usually tarnish in presence of air, yes, and that is due to the formation of the oxides or hydroxides layer on their surface. Yes, now this happens whenever we have this particular observation in the laboratories. Yes, so this is this layer, guys. Okay, sorry. So this is what we observe usually in the laboratories when a piece of sodium is taken out for analysis or for the practical purposes. If at all there's a lot of time which has gone through, then we have a blackish color layer or a dark layer which is formed quite immediately on the surface of these metals. Why? Because it gets tarnished. The surface atoms react with the oxygen in air and they form either oxides or hydroxides. Yes, fine. So in that case, definitely we keep them in mineral oil or say kerosene, by which we cut off the oxygen and the metal surface reaction. Yes. Now, over here we have been asked that we would be combusting these three elements in excess of air. Okay. So in excess of air, definitely there are different compounds. First of all, lithium is showing an exceptional behavior. Yes, because obviously it's the very first element of the group to which it belongs to, with the smallest atomic size and the highest electronegativity as well as the ionization potential. Due to all these factors, lithium shows an exceptional reaction in which it reacts in excess amount of oxygen to give us the formation of lithium oxide. Okay. Now, since we are talking about excess of air, we even have one more product being formed, since nitrogen is also present. So it forms nitride. Yes, it forms nitride also. Nitride is purely an ionic compound, lithium nitride, and it is a ruby red color solid. Yes, okay. Now that was a piece of information to be shared. What about other elements, namely sodium and potassium? If we go to look at sodium in excess of air forms its peroxide. Yes, whereas potassium in excess of air forms a superoxide. Okay, what is this? This is a superoxide in which oxygen is having a -1/2 state. Yes, in case of peroxide, yes, this is going to show us oxygen with a -1 oxidation state. So these are the different kind of reactions which these three elements show. Yes, one is a peroxide, one is a superoxide, and one is a normal oxide. So altogether we have these three oxides in a line being formed. Li2O, yes, then we are having sodium, so that would be Na2O2, and potassium will give us KO2. And this option matches with our option number 3. Okay, so I hope you understood the explanation well. Thank you.
Hello. So question says that which of the following atom, right? Which of the following atom has the highest first ionization energy, right? So we have to solve this question just by using the concept of ionization energy, right? So we know that ionization energy is that energy which is required to eject an electron from the outermost valence shell electron, right, in an gaseous state, right? So if I am taking this atom, right, this is an atom, right, and this is the nucleus, right, and this is the outermost valence shell electron, and this is electron. So if I want to eject this electron from this cell, so the amount of energy which is required, that amount of energy is called ionization energy, right? So here they are the elements, so you can say that there are the atoms which we have to tell that which of the following atoms has the highest first ionization energy, right? So we know that alkali metal, right, or you can say that S block elements has a low first ionization energy, right, and the P block elements has a high ionization energy, or you can say that the fluorine has the most electronegativity. That means you can say that fluorine, chlorine, halogen family has the highest ionization energy, right? So we know that a simple concept, if we down the group, if we go down the group, the ionization energy decreases, right? So if we go from hydrogen to lithium, right, then sodium, right, and then potassium, so it is sodium, right? So this is sodium, Na, right, Na, and then potassium, then rubidium, and then cesium, right? And there's a radioactive element, you can say that it is francium, right? So you can say that as we go down the group, right, so the ionization energy decreases because there is when we go down the group, a new addition of cell takes place, right? And so we can say that the distance between the valence shell electron and the nucleus increases. As a result, we have to supply a less amount of energy, right? So in this way, we can say that as we go down the group, ionization energy decreases, right? So here I can write as ionization energy decreases as we go down the group, right? So ionization energy decreases, right? So here I can see that this is potassium, right, and potassium has atomic number 19, right? Potassium has atomic number 19, right? So this is 19. So after 19 calcium comes, right? So and after calcium scandium comes, right? So if we move along this side, right, so you can see that if we move along the period, right, so after potassium, then calcium, then scandium, right? So this is scandium right here, right? So we know that as we move along the period, then ionization energy increases, right? As we move along the period, ionization energy increases. So we can say that in these of the elements, so we have option potassium, so potassium and sodium, right? So this is sodium and this is potassium, and after that we have rubidium, right? And this is Cg or scandium, right? So in this way, we can say that the scandium has the highest first ionization energy. That means we have to supply large of amount of energy to eject an outermost valence shell electron, right? So in this way, we can say that the scandium option C is the correct answer, right? And the option A becomes the wrong answer because it says you can say that low energy, right? Low ionization energy as compared to sodium, right? So this potassium has also a wrong answer, and rubidium also has a wrong answer, because according to this concept, we can say that the rubidium has the lowest first ionization energy, right? And the scandium has a highest ionization energy, right? So in this way, we can say that our option C becomes the right answer. So hope this answered your question. So thank you.